Sessions.
Yeah.
Okay. Now I'm just starting actually, Greg. You are able to see my screen, right?
Yes.
Yeah,
Yes.
that's good. Okay. One second. Okay. Before going into the session, I will just give a quick introduction what we are going to see today. Okay. Um. Okay. This we are going to see something called as exceptions. Okay. Let me write it down. Okay. Exceptions. Okay. So basically, what is exception is like, in Java, it is basically it is a mechanism for error handling. Okay, and it is a borrowed concept. It came from C++, and then they did some improvement. They did some improvements to the concept, and then it is more resilient in Java. Actually, we got more features in exceptions. Okay, error handling. Okay, basically, what is error handling means? Okay, you write your program. Okay, something goes wrong in the middle of your function, or something has gone wrong. Okay, what usually happen in the olden days, right? The system will automatically crash. Okay, you won't get anything. It'll just spit you an error, and then it will crash, and then the whole executable will close. Something will happen. Okay, now to avoid that problem, right? Okay, you can't do much if if the system crash or something like that, but there is something called as gracefully exiting the loop. What they mean by that is like, no, if the system crashes, something has gone wrong in the background. Okay, in the olden days it just used to disappear, the Chrome or whichever executable you are using. Okay, for example, just Chrome just will disappear without any providing any information to the user. Okay, why it has closed or anything like that. With the error handling mechanism, right? If the system does crash, I mean, if the executable does crash, means like, no, we have a mechanism of like, no, just informing the user or informing the whoever the creator of this program, like, okay, something has gone wrong, this is what has gone wrong, now I'm going to close the machine, and then what is the solution, like contact the system admin, or else restart the system, or else delete this file or something, some information to the user, saying that I'm going to close down now, something has gone wrong, you can't go any further, like that kind of information. Okay, so that is where these are the things which the error handling can do. Okay, it's a very very simple concept. Okay, and it's a very powerful concept as well, because every developer, right, and it is a must, actually it is a coding standard to use it, to use the exception handling, because the reason is like, now anytime anything can go wrong. Okay, the file you made access is might not be there in the system, or else it may not download it properly, anything, or else you may not get the mail properly. Something has gone wrong means like, no, what is supposed to happen, it hasn't happened, means like, no, your program is going to create problems, your programming is going to crash, or something is going to happen in your program which is not expected. Okay, when something happens in your program which is not expected, right, then only the error handling will come into the picture. Okay, so that is what they call the concept are called as exceptions. Okay, exception means like, no, something which you don't expect to happen, but it happened, so what do you do? Okay, that is what they call error handling. Basically, if someone asks what is exception means, like, no, it is a mechanism for error handling. Okay, we will see how the error can be handled. Okay, will be handled and can be handled. Okay, so it's a very very simple concept. Okay, to understand, if you understand it clearly. Okay, now first let me put something called as, there's three keywords you need to remember. Okay, first is try. There are a couple of keywords you need. First, basic thing is like, no, basic and most important thing is try, catch, and finally. And again, this also you will see everywhere. If you have your own program, right? I mean, if you are in your project, if you just go and check in any program or any source code, right, you will see this try catch block everywhere. Okay, Now I'm going to go a bit deep into what is how you would handle an exception. Okay. Before going there, like now I'll just give you a quick example. What are the things that could go wrong? Okay, very simple thing. Okay, then we will do how we will handle that issues. Okay, I'll call it as error handling simply. Okay, I'll put this in a package as well. Okay, exceptions. Okay, now let's do the program. Break static main string. Okay, now say for example you're doing an arithmetic operation. Okay, you can't in the mathematics, right? Anything divided by 0 is infinity, right? Which should never happen. Okay, you can't mathematically calculate a value for it. Okay, so that is a error that is a error. Okay, when I say error in the sense, like the computer can't avoid it. Okay, if you give an instruction, okay, can you divide 1 divided by 0, means like it is going to try to calculate it. Okay, when it tries to calculate it, what is going to happen is it's going to go into a infinite loop. Okay, because the answer is infinite. Okay, so there is error mechanism in Java. So that is the error scenario. Okay, your program will get stuck or it will crash or something will happen. Okay, which you don't expect. Okay, usually you won't implicitly divide by anything by 0. Okay, so how you would normally do is say for example you are writing a program to division program. Okay, so what you would do is you do scan. Okay, and then enter the numerator. Okay, and then you okay. Now this is simple program. Okay, I'm asking two values from the user. One is numerator and the denominator, and then I'm just dividing the values and then printing it out. Okay, now when I run this program, right, so it is asking for two values, so I'm just going to give 12, I'm going to give 6, I'm going to give 2. Okay, it's as simple as that. Now what would happen actually, because at the runtime, so by mistake user enters numerator is 12, and then if the user enters 0, right, what will happen? You see this, right? Something has gone wrong. Okay, you don't know what has happened. Okay, you didn't get the results. Okay, something has happened. Okay, you see, when you read this, right, what it says, exception in the thread main java.lang.arithmetic expression divided by 0, that is the error. Okay, has happened. Now what has happened now is because when the java tried to execute this line, right, so what is this line means? This line means 12 divided by 0. Okay, immediately the java the JVM knows you can't do the arithmetic operation. Okay, so what it will do is it will throw an exception from there. Okay, it is just a crash. Okay, whenever an exception is thrown, right, it means that the line of execution is coming out of there. So it executes this line, this line, this line, this line, this line, this line. Okay, when it tries to execute this line, right, it can't execute this line, so it won't go to the next line. So from here, that's what the system crashes. Just it will just come out with an exit code. Okay, the system will crash, but it won't simply crash. It will throw an exception and then crash. Okay, what that exception will have is like, no, we will have information about why the system has crashed. Okay, when I say system has crashed means why the program has exited. Okay, without executing the next line, or further you can have any number of lines further down. Okay, the reason why it has exited from this line itself, right, this is the reason. Okay, you read this one, Java there is an arithmetic exception has been thrown, and then the reason is divided by 0. And then it will have some more information also. If you click this one, right, it just says that where the error has happened. Okay, it is in the program called as error handling.java. It is this program, and the line number is 15. If you click this one, right, if you see this one, right, you can see this one, 15th line. So it gives you more information about the error, what has happened. So going back to my old statement, in the olden days when the system crashes, right, it will just crash. Okay, if this has happened in the C programming, right, you won't get any of this information. Okay, you will get, you won't, only difference between the C and Java here, right, you won't get this information. It will just simply throw this one. Okay, so you would have entered 12 value, you would have entered 0, and then it will immediately say process finished with exit code 1, but it won't print out anything. So the user won't know anything. Okay, this is a simple thing. Okay, we know what it is. Okay, but in the complex program, right, user won't know why the system has exited. He was expecting results to be printed, but the system has exited. Okay, so in Java, what they introduced was like, no, wherever this kind of like, no, unexpected behavior happens, right, unexpected error happens, it is going to be handled gracefully. Okay, so what they did was like, no, they introduced a concept called as exception. So whenever there is a issue, right, what will just get your mind around it. Okay, whenever this kind of error happens, right, what JVM will throw is like, no, JVM will throw an exception. Okay, when I will go a bit deeper later. Okay, what throwing exception means. Okay, now called as, it will raise an exception. Okay, it will raise an exception, and then the exception will have further information about what was the cause of the issue. Okay, so that's all you have to need to know at this point. Okay, so we have seen one very simple example of what could cause an exception. Okay, now let's go ahead and see. Okay, this, you see this one, right, this is handled by Java itself. But in many circumstances, right, if an exception happens, means the user has to handle it. I mean, the programmer has to handle it, because in our coding, right, say for example, oh yeah, okay, we are running set of tests. Okay, we have run for the list of tests is going to be 50. Okay, say for example 15 tests has successfully executed, and suddenly the 16th test has failed. Okay, so what will happen in the normal system crash means, if you don't handle it, no, it will just come out of the program. Okay, it won't do anything. Okay, but what you would do is like, no, what as an automation programmer, right, what you have to do is like, no, you have to catch the exception. Okay, when I say catch the exception means like, no, I will tell you what it is. Okay, you have to catch that exception and do some operations. Okay, as for the safety mechanism, when I say safety mechanism, in the sense like, no, write a log file saying that, okay, when I was executing the 16th test, system got crashed, 15 tests has been executed successfully, and then I will save the report in the file for the 15 test cases results, and then just put information in the log file saying that I'm not going to do any more further because the system has crashed, and then come out of it. That's it. So the only difference between the earlier and this time is like, no, you have additional information in the log, and then you have saved the 15 tests which you ran successfully, right? It is not going to waste actually. So there, like, no, the behavior was handled by you. Okay, I will repeat it again. So here, when an exception happened, right, Java handled the exception. Okay, but in pretty much most of the circumstances, when you are doing the Java project, right, the programmer has to handle the exception. Okay, it's very simple, and I'll show you how to handle the exception. Okay, now, okay, that is where this try and catch comes into the picture. Okay, so there is something called as try block. Okay, so what I mean by this, like, no, so if you put try, and then it's just simple block. Okay, you can have any kind of code inside this one. Okay, if you have, so whenever you do a try block, right, it should be followed with a catch block. Okay, okay, so first remember this one, okay? Whenever you do a try block, it should go with the catch block, okay? It's really simple, okay? So what it means is like now, so whatever, so the code you have got inside this try block, right? If any piece of this code throws an exception, right? That exception can be caught in this catch block, and then you can do certain operation here, okay? So I'll show you. I will demonstrate that to you guys. Okay? So it's really simple, okay? I'm going this piece of code here, right? I'm going to put this in the try block, okay? Let's see. So it's simple, okay? I'll first just show you guys, okay? Because why it's immediately complaining is like, no, because it should followed by catch, okay? Catch. Now I'll do specific. Oh, sorry. Okay, so now what I'm going to do is right now I'm going to put this block inside this one. Maybe. Now I'm just going to show you one small thing before. Just to show you guys how the the line of execution jumps from there to the catch block, okay? Okay, now so if I run this one again, okay, let's run this again. I'm going to do this same thing after 0. You see this one, right? You got the line called as before division, okay? So this line has been executed, okay? So it comes from top, this line executed, this line executed, this line executed, this line executed when you enter the second value, okay? Now this line also got executed, okay? And then when it tries to execute this one, right, that's where the error is. So the execution jumps immediately from there to the goes outside of this one, okay? You see, that's why you don't see this two printout statements. The after division never get printed out, okay? So what would happen is like, no, the line of execution will jump from this line of code, line 17, and it will jump to the catch block, okay? When I say what I mean by this, like, no, so the catch block, right? Catch block is the sole purpose of the catch block, like, no, is to catch the exceptions thrown inside the try block, okay? So whenever anything goes wrong inside the try block, right? If an exception is thrown inside the try block, that can be caught by the catch. That can be caught by the catch block, okay? So and then you have to see this one, okay? So the what is a possible, there are many types of exceptions are there, okay? There is arithmetic exception, array index bound of exception, okay? I will just quickly, that is very easy to demonstrate, okay? If I say, for example, I am declaring an array, okay? That is also an error scenario, okay? Int yeah. Oh, sorry. Okay. Now, so what I've done is like, now I've created an array which can have 10 values. Now, say for example, I'm trying to do this, okay? This is a perfectly valid statement, okay? So like, okay. So this is a perfectly, but this one, this is not a valid statement. The reason is because you are trying to access something, which is how see, this itself is compiling, because it's not a compilation error. You are perfectly valid to compile it, okay? So what's happening is like, you're trying to access something illegal memory. When I say illegal memory, in the sense like, because of this array, right, only 10 integers has been allocated to this variable, but you're trying to access the 12th variable, sorry, 12th index, the value of the 12th index. So that is called something called as, from the name itself I'll tell you the name of the exception, array index out of bound exception. Okay, it's, the name itself is self explanatory. If I run this one, right, you will get that exception. You see this one, right? Array index out of bound exception. Okay, whenever you see this word array index out of bound exception, it means that something somewhere is trying to access an array which outside the limit. Okay, that's what this exception means. Okay, now you can ask a question. Okay, this exception is in this again. Okay, if I put the same thing here. After array, before array. Okay, now again if you see means it will end there itself. None of these following lines will be executed. It will start, it will print out before array, that's it. Don't worry about this collapse of this one. Okay, because that's Java printing out the same. Okay, so first only before array has happened. Okay, the only this line got executed, and after that when it tries to execute this line, right, immediately the system didn't crash. I mean, the something has gone wrong in your program, and then it has to come outside of it because it can't execute this line. It's not supposed to execute any of the following lines as well. Okay, so it has come outside of this one. Now you can ask a question like, okay, we got a catch block, right? Why this exception was not caught by this catch block? It's very simple. Okay, the catch block, right, you have to say what type of exception you want to catch, because I have told arithmetic exception, right, it can catch only arithmetic exception. Okay, because this exception what thrown by this line, right, that is not an arithmetic exception, that is an array index out of bound exception. So Java handled it. Okay, if you see something like this, right, it means that Java handled it. Okay, so if you want to handle this exception by the user also, right, you can add another catch block. Okay,
excuse me, Bala, do we always need to specify the exception name, or we can just put exception, catch exception?
Yeah, I will come to that in a minute actually. Yeah. Okay. What was it? Yeah, okay. I'll just put a tag simply. Custom array index bound. Okay, and this is also custom what is it? Arithmetic exception. Okay. Now, if I run this one now, right, now you won't get any of this information. Okay, what all you will get is this block will get executed. Okay. See this one, custom array index out of bound exception, because the exception which was thrown in this line, right, that is caught by this catch block. Okay, like this way, right, you can have as many number of catch block you want. Okay, the reason why they go for this kind of individual catch blocks is, right, like, because different failures requires different error handling. Okay, now so these are all very simple things. Okay, in the real time, right, say for example the file accessing has gone wrong. Okay, and then you are trying to recover from the file so the file you are looking for is not there. Okay, so you're trying to recover from there, means you will have a certain set of operation saying that, okay, I'm going to create that file, I'm going to search for that file or something like that. Okay, now say for example the network connection is not available, right, it can't be handled by the same catch block where the file was missing. Okay, so you have written a logic. If the file is missing, means you have written a logic in the catch block what should happen. Okay, the same catch block can't be applied for the network failure also. For the network failure, right, you need a separate catch block. Okay, what should happen with the network failure? You are not able to establish connection, means you retry the connection, or else you shut down the existing HTTP connection and then restart it again, or something, some kind of error recovery mechanism, or else logging mechanism. So that is the reason they go for this different catch blocks. Okay, because here we are seeing very simple thing, but in the real time program, right, it will be there will be complex code will be there, and then different exception needs different error handling mechanism. That's why they go for this the different catch blocks. Okay, this is how they will do it. Okay, and then what will do in always what they will do is like no, they will never let Java to handle that exception, because Java what will do is like no, it will just print out the error saying that this is what the error has happened, and it will just come out of it. It won't do any kind of error recovery mechanism or anything, because that all those things needs to be done by the user, by the programmer. Okay, now what they will do is like no, say for example we know that two possible things can happen. Okay, what is numerator and the denominator, divide by zero error, and then that is arithmetic exception, and then one is array index out of bound exception. Say for example, is that there is a possibility some other also can go wrong. Okay, when I say when you do the system scanner.in, right? Say for example, there is no input interface is there. Okay, there is no keyboard is there. Something has gone wrong. Okay, in which is not under the bound of arithmetic or array index bound. Okay, what I mean by that is like no, so you don't know what is going to go wrong. Okay, you have anticipated there can be a divide by zero error, so you have put arithmetic exception. You have anticipated there might be a try to access the array index out of bound, so you have put array index out of bound exception also. But there is a possibility of some error can happen which you don't know which is going to happen. Okay, you don't what I mean by that, you don't know the name of the exception which is going to happen. So at the time what you will do is like no, you can put something like catch exception E. Okay, this exception, right, all the exception will end with a word called as exception. Okay, all specific exceptions, arithmetic exception, array index bound of exception. I can't spell the I can't pronounce the word exception. Okay, fastly. Okay, so all the exceptions can be caught by the single. All these are classes. Okay, and you're just creating this is just again like a method call. Okay, now all this exception can be caught by the exception class, because this is the parent class for all the exceptions. Okay, I will go deep into that, don't worry about it. So just remember this thing alone now. Okay, so you don't know what exception is going to happen apart from the arithmetic and array index out of bound. Okay, so if you want to handle that kind of unknown exception also, right, you can simply put exception E, and that will be handled by this one. Okay, so I'm just going to put a S out. So what because the reason why this is useful in the sense is like now, because when you leave it to Java to handle it, right, it won't do anything. Okay, it will just print out and leave it. Okay, so what you want to do is like now, whenever in your usual program, right, because when you run some program overnight and then come tomorrow morning and you don't see any information, right, that is frustrating. You want to know where it has failed and when it has failed, why it has failed, and all this information. Okay, so what you do is like you will catch that exception. This is unknown error. Catch that exception, like, and then afterwards what you will do, you will put more information in the log saying that okay, in this line the error has happened, and during this time of the day the error has happened, and I have completed this many number of test cases before, and this is the what current test case I am trying to execute. Those kind of information you will put in the log, so that tomorrow when the system, even though the system crashed, right, when you come to check your execution, you will know why it has. You will have more information to handle it. Okay, so to investigate, to be clear. Okay, now I'm going to demonstrate this catch exception. Okay, how it is useful. Okay, now what you can do is like now you can just comment out these two. Okay, so earlier what I demonstrated, right, when I had just arithmetic operation, right, it couldn't catch array index out of bound exception. Okay, just comment out this one. Okay, so when this one throws array index out of bound exception, right, it can't be caught by arithmetic exception. It will go outside of this one, and then Java will handle it. Okay, if I run this one, see, sorry, before I printed out, and then the line of execution has been thrown to Java. Okay, you are not seeing this custom arithmetic exception. Okay, because this catch block can handle only arithmetic exception. It can't handle array index out of bound exception. But if I show you this one, right, one second, Okay, if I show you this catch exception, right? See, this exception can handle any exception. Okay, yeah, I'll just comment out this one. It can, so I just showed you this exception can handle array index out of bound. In the same way, it can handle arithmetic exception also. Just put the values. See, not sure what exception is being thrown. So whatever. So basically, what will happen is like now, if that exception happen, if the error is thrown from there, it will immediately jump here, and then whatever block your piece of code you have put, right, it will get executed. Okay, now I hope you guys understood try and catch block. Okay, what is try and catch block? Okay, I'll just quickly summarize. Okay, so when you know that you are doing some sensitive programming, okay, you usually what they will do is like, they will write it inside the try block. Okay, why they do it inside the try block, right? When an error happens, and then inside the try block, that can be handled by a catch block. Okay, that can be caught by that error can be caught by the catch block and take necessary actions. What should be done if an error has happened? Okay, rather than just crashing out of the system. Okay, it's going to crash definitely, because whenever an exception is thrown, right, you can't execute any number of any of following lines. Okay, so that is the reason why you have the that is the reason why you have the catch block. Okay, now just let's go inside this. What is this thing is? Okay, this what is this variable is? Okay, so E will have this E, right, that is actually an object. Okay, because you created a reference, and then whenever it fails, right, Java will put a exception here. Okay, information about why the system has failed and where the system has failed. Okay, I'm just going to show you what are the things available inside that thing. Okay, so if I put get message, right, just print out this one. Okay. It'll have more information. Okay, I'm going to do this one. Okay, rather than entering values every time. And oh yeah, sorry, I forgot. Okay, so this told, right, okay, yeah. See, error message is just told. What this told means is like now you are trying to access something in the 12th index. Okay, that's why this 12th information is. Okay, you can get a lot of information from this one. Okay, if you do this one, right, and then there is a very simple thing which everyone uses. You need to remember, it's like print stack trace. So if you do this, right, you don't need anything else. Okay, it will just print out what is the cause and everything, pretty much most of the things. Okay, see, so it's basically what Java does actually, but that is what you can get out of it. If you put e.print stack trace, right, so what is printing out right now? So what is the cause of the exception? What is the exception? What kind of exception has been thrown, and what is the message inside that exception, and which line the error has happened? Okay, you can access all this information here. Okay, and then get e dot get stack trace. Yeah, okay, so if you do print stack trace, it will just directly print it out into the screen. Okay, but if you want to write it in a log or something, if you want to save it somewhere, right, you can use this get stack trace. That will have all the information you want. Okay, so I'm not going to go deep into this one. What is get stack trace? I want you guys to go fiddle around with this one. Okay, what is get stack trace and how to extract the elements from that one. Okay, it will just have this information, but it will have it in a string. Okay, because and then using that string you can do anything you want. Usually what they will do is like, they will write it in a log file what is the reason it has failed. Okay, I'm going to give a bit insight into why this exception can handle all the exceptions. Okay, all the type of exception. Why arithmetic can't handle array index of unknown, or also vice versa, array index bound can't handle arithmetic. But this exception, right? This is general class. Okay, that can handle all the exceptions. Okay, the reason is this. You see this exception, right? That is a parent. It's a parent or interface. I'm not sure, but it is a parent. Okay, sorry. I'm not sure if it's a class or interface, but it is a parent for all the type of exception. Okay, wherever you see a word called as exception, any type of exception in Java, right? It will be a child class called as exception. Okay, let's gonna see. Okay, arithmetic exception. Okay, just Java. So this is there is a class called arithmetic exception. Okay, so yeah, exception, that's a class. Yeah, okay. So you see this, right? This arithmetic exception, it is directly or indirectly a child of this exception. Okay, this exception class. Now if you look into this exception, right, these are all the possible exceptions that can happen in the Java. Okay, basically I'm again I'm very stressing in Java. Okay, Selenium will have for example, Selenium architecture, right? It will have its own exceptions. Okay, they will have any libraries, whoever uses libraries or whoever does programming, right? They will have their own exceptions. Okay, their own types of exception. Okay, if you look inside this one, right, array index out of bound. Right, spelling mistake. Oh, these are all direct subclasses. Okay, so let's that was my mistake. Okay, so let's go for the array index out of bound.
I think you have the runtime exception, and then there will be.
Yeah, if I go to the runtime exception, it will be the, I think, array index out of bound will be here. No, it's not. Okay, let's look into it. But it will be definitely a child class of exception. But that's what I'm saying. It will be either directly or indirectly. Okay, let's look into this array index out of exception. Oh, there is another. So exception. There is a runtime exception. That is runtime exception is there is another child runtime exception. There is another child for it index out of bound exception. There is another child array index out of bound exception. So this exception, right, that will be either be directly or indirectly a parent of all types of exceptions. Okay, all type of exception that happens in Java. Okay, that is the reason, because it's a parent of all the exceptions, right? That is the reason that exception that class can handle all type of exceptions. Okay, that is the reason. Now, yeah, okay.
Sorry, Bala. So I see there is another class which is parent to exception, which is throwable.
Oh, throwable. No, that's again, you can't do cache block can have throwable. Okay.
You can. Okay, I see. You can like use exception and error. So that's like throwable.
Yeah, because exception is. I mean, yeah, there is a limitation. Okay, if you put, you can't put any class here. Okay, if say for example, sorry, and you can't. Yeah, if I put throwable here, right? Let's see what happens. I guess it will be handled as well. Actually, 1 second. Let me come on top of this one. Yeah, because again, throwable is a parent class for everything, but you can't put, say for example, we got something called A1, right? See, it will immediately throw. Okay, so it should be a child. It should be a child of throwable. Okay, that is why it is complaining. You can't put any class here. Okay, so what you will do is like, no, you will do throwable. Okay, the reason why you don't do throwable is like, no, because you know that information. 1 second. There are additional things available in the exceptions.
It's not that because throwable can handle also errors.
No, throwable can handle everything as well, because throwable is a parent class of exception, right? It can handle everything. So it's like, okay, so how I told you, say for example, let's go one step beyond this one. Okay, array index out of bound exception. So don't think of exception or runtime exception or everything. Okay, if it is a parent class of the exception what you wanted to handle, right, that can also handle this one. Okay, it's as simple as that one. Okay, say for example array index out of bound exception, right, that can be handled by index out of bound exception class also. You can put runtime exception also, that can be handled. Usually we'll do exception. Okay, the reason is I'll tell you the reason. Actually I know the reason. Actually supply with because it has got additional it has got constructors. Yes, and throwable won't have certain constructors to it. String message, string class. What are the additional things are there in the exception? Just got throwable cause. Okay. Okay, yeah, there is something called as checked and unchecked exception. That is next. I'm going to talk about that one in a few minutes. Okay, now that is the concept. Okay, you don't need to think of exception or throwable or anything like that. Okay, again, what did I tell you guys? Okay, so if it is a parent of that exception, right, that class can handle the exception. Okay, so now what is the problem here is right. This A1 class, right? A1 is not A1 is not a it's not a child of throwable, or else it is not a child of exception or anything like that. Okay, it's got nothing to do with the exception, so you can't use that class here. Okay, so usually in a general sense, right, you always use exception. Okay, here if you don't know what kind of exception is going to throw in, right, you'll use exception. Okay, because this is a parent class of all the exceptions whatever you're going to come across in Java, right, that it will be a child of this exception class. Okay, so you can use this class to handle all the unknown errors. Okay, all the unknown errors, or else if you don't want to go into this creating multiple catch blocks, you just want to just finish the program quickly, means like, no, you can do it here. Usually in the testing architecture, right, you don't need a multiple blocks, because it is not advisable, but it is not a grave problem for us actually. But for the development side, right, if you want to do development, right, you have to have individual catch blocks, because there you have to take different actions needs to be taken based on the what kind of exception is being thrown. Okay, so when you are doing testing regression pack, creating a testing automation pack, right, you can just use general exception, okay, to catch everything. It's not a problem. It's not a bad programming. Okay, so don't worry about it. Now, okay, so to summarize it, okay, try block will have certain big pieces of code, and then if any time an error happen there, means like, no, it will look for a catch block, whether the catch block can handle it. If the catch block can handle it, it will be able to handle it. And then what will happen is if there is no catch block to handle that kind of exception, means Java, it will be given to JVM, and JVM will handle that exception. Okay, now I assume you guys understood what is simply try catch block means. Okay, again, I just wanted you guys to understand the concept alone. Okay, now when you try to do this one on your own, right, then only you will have some doubts and new things. Okay, and then again, this is a very basic and then important concept. And then so if you look at any kind of development work, right, you will see this everywhere. Okay, now I'm going to talk about one more thing called as finally block. Okay, now let's do something here. Okay, so the catch block has got executed. Now if we do this, you see this one, right? It has come here. Okay, now what will happen is what you usually do is like, now say for example, yeah, okay, now what you've done is like in the try block, right, we haven't gone for the file opening. Okay, let me give you some other example. Okay, so you have started a conversation with, say for example, in your program, right, you have started a conversation with the customer. Okay, so don't worry about any of this one. Okay, you've started a conversation with the customer. Okay, started a conversation with the customer. Okay, now, so what has happened is like, you're doing certain operations after that. Okay, so what you will do is like in your try block, right, you will do certain operations. Okay, once all the operations are done, right, what will be the final thing what you will do is right now, what you will do the final, what will be the final thing you do normally when you are in a call, when you're talking to a customer. So for example, you will say a goodbye message, or else thank for your feedback, or something, some kind of general information, right? Okay, so what is like greeting message. Okay, customer greeting message. Okay, so what you do is right now you started a conversation, and the conversation keeps going on, and then in the end, once you're done with the conversation, what you'll do, you'll end the conversation and send a greeting message to the customer. So what is the problem now is right now, if something goes wrong in this in here, right, what will happen is right now this piece of code will never get executed. Okay, where it is actually sending a greeting to the greeting message to the user. Okay, so in that case, right, so you want that piece of code to get executed. You want to send a greeting message to the to the customer, even if in both circumstances. When I say both circumstances right now, whether it's successful, nothing has gone wrong. There two things can happen. Okay, after you start the conversation, everything can go correctly, or else something can go wrong. Okay, you want in both the circumstances, you want some piece of code to get executed, means you will have something called as finally block. Okay, finally. Okay, now what I will do is like I'll just do something here. Okay, goodbye customer. Okay, now, okay, so what I'm saying, okay, what I'm trying to say here is like now, if an exception has been if say for example, this is assume that this is a piece of code where the normal conversation happens. Okay, now where you can put this piece of code, goodbye customer, once you do all the operations, once you have done all the operations, you can put this conversation. Okay, now what will happen is right, if I simply comment, okay, let's keep it this one. Okay, I'll do this in a second. Not customer. Understand. No. Okay. Okay, I've done a division program and I am asking the customer to use it. Okay, now, so for example, if I do this, okay, so good morning customer, please use my division program. Okay, now I enter value 12. If I enter value 6, okay, I'm not demonstrating this at the moment. I'll just, so now let me just work on. Okay, now, okay, so goodbye customer is here. So I'll just run this one. Okay, it's a simple. Okay, 12. I'll do the 6. Okay. Before division, after division printout is also there, but don't worry about it. I'll just comment on this one. Okay, now in the end, what we got is messages goodbye customer. It's everything is well and good. So the user has got a message. Okay, goodbye. But if something goes wrong, means like no. So 12, it will be 0. See, not sure what exception is being. So it has been caught by this exception block. And then what has happened is you don't get this message. The reason is what I told you guys was like the line of execution, right? It will jump from this line to this one. Okay, so any piece of code after that will never get executed. Okay, so the user will never get a message called as goodbye customer. Okay, now what the next thing what you will say is like, no, okay, you can place this information in the catch block. That's well and good, but the problem there is like, no, if something goes wrong, right? Okay, let's do this one. Okay, again 12 0, something has gone wrong. Okay, not sure what exception one, but you get a goodbye customer message. But if everything goes rightly means right now, don't see, get to, you won't get that information. Okay, so what has happened is like, no, so only if the error is thrown, right, you will get a goodbye message. Okay, if everything goes right, you won't get the goodbye message. The next possible solution, what you will say is like, no, okay, can we have both of this? This is very bad programming. When I say very bad programming, like, no, programming 101 is right. You can't have the same piece of code done twice. You should never write the same piece of code again and again. Okay. Here we are just seeing one line, but in the normal circumstance, right? Say for example, you have opened a file to read. Something has gone wrong, but you haven't closed it. Okay. Because whenever there is in Java, right? Whenever you, say for example, whenever you open a file to read it, right? You have to close it. Okay. That is a good programming. But something has gone wrong in the middle. Okay. So the system will crash without closing the file itself. Okay, so you have to put that close, you have to execute that closing of the file operation, irrespective of whether it has gone right or bad. Okay, whether the program has executed successfully or not, you have to close the file. Okay, those kind of sensitive piece of code which needs to happen irrespective of whatever happens, right? You will put it in a block called as finally block. So that is what it is called. Okay, now if I do this, if I paste this code in the right, after catch block, if I create a block called as finally block, right, irrespective of whether the exception is being thrown or not, this piece of code will always get executed. Okay, you can never get rid of this code. When I say the Java can never skip this code. Okay, it doesn't matter where the exception has been thrown, this piece of code will always get executed. Okay, let's run this one. 12 2, see the try block, because once the try block is done, so what the concept is right now, once it comes out of the try block, right, it can be handled like exception, but the finally will definitely happen. Okay, so what it means is like, if you have a final block for the try block, right, again I will rephrase the statement. If you have a finally block for the try block, right, once the try block is done, the final block will get executed. Okay, if something goes wrong in the try block also, final block will get executed. Okay, in between only one additional thing will happen. It will try to catch the exception. Okay, the Java will try to catch, so you can have your own catch block to catch an exception. Okay, now you can have just try and finally also. You don't need, catch is not always a mandatory. So always a try block should be followed by either a catch or finally. Okay, now I showed you normal execution. I'll show you one thing where something has gone wrong. 0. See this one. There also this piece of code. There's something has gone wrong. Exception that exception has been thrown in this line. This line will never get executed. Exception is being thrown and it has been caught by this catch block, but still this block get executed because, as I told you, finally block can never be skipped by Java. Okay, finally block will get executed irrespective of whether everything has gone wrong, right or wrong, right way or else wrong way. Okay. Finally block is like it's like a safety mechanism. Like the file opening and closing is one of the good example. And then usually what they will do is like the log. Usually what they will put here, like we will record the test execution time, right? Test start time and the test end time. So irrespective of whether okay, something has gone. Say for example, you start your test. In the first line you print out what is the current time. Okay, and then you keep on going on. Sorry, you keep on going on. Okay, something has gone wrong means like in that circumstance, also you need to know how much time that particular test has taken means you will put that information in the finally block. So what will happen is irrespective of how much time it has taken, it will be recorded. Okay, whether it has gone correctly or in the wrong way. Okay, I'll just demonstrate that. Okay, it's not hard to demonstrate. So it will give the current time in the milliseconds. Okay, that's what I'm just starting here. Some time to see the total time take 2768, that is 2.7 seconds. Okay, total operations from here to here. Okay, now if something goes wrong, right, usually they will save this time in a file, in the log file, saying that how much time the test has taken. So if something goes wrong, you won't get that information. This will never happen. So it will be very good to put this block in the finally block. You have to do one small operation, because as I told you, right, the start time is not available here, because every variable you create, right, the scope of that variable belongs only inside the block. When I say block, in this flower bracket and open bracket, so you have created the start time inside the try block, so that start time variable can be accessed only inside this block. Okay, to get rid of that solution problem, what you do is, you usually just put you will do it like this. Okay, you will declare the start time there, but you will actually, they will say, do the value here. Okay, okay, the reason why the error immediately disappears, the reason is because the start time is not now available for both try and finally block. Okay, because finally, where in which block the start time belongs to is the parent block of this finally block. Okay, the parent block is this main block. Okay, this one. Okay, that's where the start time belongs to. So that's where it's accessible. Now if you do, right, so it took 4 seconds. 0, it took 3 seconds. Irrespective of whether error has happened or not, this line of this finally block will always get executed. Okay, that is why it's so important as well. Okay, now these are the 3 things which is very, very important in your thing. Okay, there is only one other thing. Okay, I'm going to explain that concept very, very top level, because you will never implement it. Okay, we are never going to create our own exception, because in the development cycle, right, they will create their own exceptions, like how arithmetic exception is there, right, likewise they will throw their own exceptions. Okay, because they will put custom information inside in it. Okay, so but in when I was doing the test back in all my experience, right, I have never created my own exception. When I was a developer, I have done it, but so in the testing, when you're going for testing, right, you really don't need it. So I'm going to explain the concept of checked exception and unchecked exception at the top level, and then from that one onwards I will tell you what it is and how it is used. Okay, that's a very simple concept. You just need to remember it, why it is. Okay, when you come across. Okay, so the most important thing in this one is, like, in the exception handling is, right, they call it exception handling. Okay, that is a word they will use again and again. Okay, so most important thing in exception handling, you just need to know 3 things. Okay, one is try, catch, finally. Okay, these are the 3 important keywords. Okay, try is a block where you will put all your source code. Okay, catch is a block where you will have information what needs to be done if an error has happened. Okay, in the catch block. And finally block will be a safety mechanism piece of block which will get executed irrespective of fact whether the try block has gone successfully or not. Okay, when I say successfully or not, if an exception has been thrown or not, because when an exception is thrown means the line of execution will jump from that line to immediately to the catch block. Okay, that's what we have demonstrated. So it will jump from here to immediately to the catch block. So because of that, whenever error happens, you don't see this piece of code get executed. You're not seeing the result here, right? Result result print statement. Okay, now, so these are the only three things important. Okay, I'm going to tell you what is checked and unchecked exception. Okay, now, okay, I don't need to go here. Okay. So, okay, checked exception means like now the compiler itself will check for an exception if that can happen or not. Okay, so what I mean by that is, right, in this line of code, right, when you do this numerator by denominator, right, there is a possibility that in wherever you do a division, right, there is a possibility it can be divided by 0. Okay, so but the compiler won't check for those kind of things. Okay, because the compiler, it is the arithmetic exception, right, that is not a checked exception. Okay, but there is a concept called as checked exception. When I say checked exception, means like now if you want to do that certain operation, right, you have to handle that exception. Okay, I'll put deep here. Okay, before that I just want to demonstrate one small thing to you guys. Okay, now okay, we are doing main here, right? I'm just going to copy the whole piece of code into something else. Okay, this is going to create a method. Okay, I'm just going to call that. Okay, now it's the same thing. Okay, now you see this, right? If I run this one, it's exactly the same thing and nothing has changed. Okay, so only difference is all I'm doing is I'm just created a method. Okay, now say for example I don't have any try catch block in this method. Okay, now let's put this one into perspective. Okay, I'm just going to come just to show you guys, I'm just going to come onto the whole thing. Okay, I'm just gonna wait, just do that away. Okay, come out. No, okay. Okay, it's simple. Okay, I'm in a single line I'm creating an exception. Okay, so you see this one, right? Okay, this is what the stack of this is what they call it a stack trace. Okay, so now what it means is like now the method so this is the error that has happened. Okay, and if you follow the lines, right, what the first line what it will say is right, immediately where the error has happened. Okay, it has error has happened in something called as what is this one. Okay, exceptions is the package name and the error handling is a class name and demo is a method name. Okay, in that method in the line number 19 the error has happened, the exception has happened. Okay, and where this demo has been called by this main method. Okay, that's what this main method, and in which line that is main method is calling the demo method, it's here. Okay, you can it like this way it will show you the stack trace. Okay, because the exception, right, exception gradually, when an exception is thrown from this line, right, it just gets propagated upper and upper. When I say propagated upper and upper means like now, so from the demo, right, the exception will be thrown to the main line, the main program, and from the main program it will be thrown to the Java. Okay, so let's do something here. Okay, yeah, I have to explain the checked and unchecked exception in the next class, guys. I'll just go deep inside this one because I'm pretty sure that's going to take some time. Okay, explaining this concept. Okay, now so if I run this one, right, See this one, right? Only before get printed, after didn't get printed, print. Okay. Okay, if I run this one, you see this, right? Before in main method, before in demo method has happened, but none of the after didn't print. Okay, so let's see the line of execution. Okay, it starts from this line. Okay, so it will print out this statement. That's what you get before in main method. Okay, then a method is being called. Okay, it will jump inside this method. Now again, what is the first line of execution? This line will get executed. Now after this line of execution, right, an exception has been happened. Okay, something has gone wrong. Now what I told you was like, no, it will immediately jump out from this. It will never execute any lines after this code. Okay, so it will come back here. Okay, it will come back to this method. Okay, because this method is being called here. Here also, right, it won't do anything. Okay, here also from this line, it was executing this line. From because of that line only it went here. Okay, so exception has happened, so it has come back here. Okay, it won't execute any of the following lines also. From here it will jump outside. It will go outside like that, step by step. So what you can do is like, no, you can handle the error here also. You can put a try block here also. Okay, so usually what we will do is, right, we'll do this. Try catch. Okay, this is how you normally handle an exception. Okay, see, this has happened. Yeah, the reason why it is getting printed like now, here itself you have handled the catch block. Okay, now what has happened is, okay, before this line of piece of code get executed. Okay, now let's do one more thing. Just put inside try block. You won't see this inside try block. Okay, so before this has been happened, and this has called this method demo, and then it has come here. It has printed out before demo method, before in demo, and then error has happened, and it has been caught by this catch block. So immediately you will see the custom message, and then immediately the line of the execution will start from here onwards. Okay, the system. So that's why this line is getting printed, and then it has jumped back here, and then that's why this line is getting printed now, because we have handled the exception. Now it is safe to follow it. Okay. Now what is not safe to execute is, right, whatever inside the try block after the error, right, that is not safe to handle. Okay, what piece of code you will usually put outside the try, right, even if something goes wrong here, which is safe to get executed, right, which is safe to get executed, that is the only piece of code you will put outside the try block, because whichever you know that you need to safeguard, right, whatever operations which can happen only if the previous line is successfully executed. Those kind of code you will put inside the try block. So say for example you want to print out the I. I want to print out I. Okay, now this line of code, right, can't be executed without this line, because the reason is like now this line has to execute successfully, otherwise I variable will never be created and you can't print it. Okay, if something goes wrong here, right, you can't execute this line. Okay, which will result in bigger problem. That is the reason usually when something goes wrong inside a try block, right, immediately the line of execution jumps from there to the catch block. Immediately it will skip all the code here. Okay, now when I say, remember that statement very carefully. Okay, it will immediately jump to the catch block. Okay, again I'm stressing, it will jump to the catch block. It won't jump anywhere. Okay, it will search for a catch block, and then wherever the catch block is there, it will jump there. Okay, if you don't have a catch block, right, let's see what happens. even though this is a catch block, that exception can't be handled here. You see, you won't see any of this after methods, because the reason is it is searching for the catch block. Okay, an error has happened and it is searching for a arithmetic exception catch block, and it couldn't see the catch block, and then so it won't execute this one because the exception hasn't been handled yet. So the Java won't know that it is safe to start the execution. It will keep searching for the catch block. Okay, if it couldn't find the catch block anywhere, it will go back to the JVM. Okay, so what I mean is like now it will search for a catch block here. Okay, there is no catch block here, and then again it will come and see here. Okay, again if there is no catch block here also, right, it will jump backwards. Okay, from main. Who is called main? Java is called main. Okay, so Java will handle the exception. So I was going to demonstrate to you how we can handle here. Okay, it's pretty simple. You can have a type block here, catch, okay. Now if you see, if I run this one, right, see this one, right, exception is handled in the main block. Again, just remember this, guys. Okay, so everything usually how the function call will happen, right, it is like a stack trace. They will call it stack trace. Okay, what is stack means? Like, no, stack means first in first out. Okay, when I say in a queue, right, so if you arrange a stack of books, right, say for example you place a book 5 first, you place book 4 on the top, book 3 on top, book 2 on top, book 1 on top of that. Okay, to access the book 5, you can't access the book 5. The first thing what you can access is, because you can, don't think that okay, you can put your hand down. Okay, not like that. Okay, so in a stack concept, right, the only way to access the what is available for you to access is, you have to get it of book 1 to access the book 2, and the same way you have to access the book 2 to access the book 3. You have to remove the book 3 to access book 4, and then the same way you have to access book 4 to book 5. So that is what they call it, first in and first out. So last in first out. Yeah, sorry guys, not first in first out. First in first out is queue. Okay, stack is last in first out. These concepts I studied in college times. Yeah, last in first out. Stack is a container of object that is inserted last in first out. Okay, whichever you have put last, right, that is the first thing that is going to come out. Okay, so book 5, book 4, book 3, book 2, book 1. So book 1 is the last one that has come inside. Okay, the first one to go, so it will be obviously book 1. Okay, but in a queue, right, queue is a different way, because queue normally what happens in a theater, if you stand in a queue, right, who has gone first, right, they will only first go out. Okay, it's just a concept. Okay, in the queue is different from stack. Okay, that's what they call this LIFO and FIFO. Okay, LIFO means last in first out, FIFO means first in first out. Okay, so why I came here, stack trace. Okay, yeah, method calls. Okay, so say for example, if there is a main method, it calls a method called it calls method 1. Okay, and then it calls method 2. And then it calls method 3. Okay, I'll just define the method 3 here. Now, okay. Okay, execution. Okay, now what will happen is, right now from main, right, the method 1 will be called. Okay, so there will be think of an imaginary stack. Okay, when I say imaginary stack, in the sense, okay, so when first method that is being called is main method. Okay, so it will be placed in the stack main method. Okay, so from the main method, what method is being called? Method 1. Okay, so it will be done by method 1. Okay, now immediately from method 1, where the jump execution has happened, when it executes the method 1, what has happened is the line of execution has jumped to method 2. Okay, so method 2 will be placed in the stack on top. So just put method 2 and same way method 3. Okay, now what this means is like, no, so whenever Java tries to execute, right, so it will follow the stack method. So it will first execute the method 3, then after executing the method 3 it will remove the method 3 from the stack. So when I say method executing means it will complete this operation. From there it will jump here. Okay, so now it will restart the execution of method 2. When I say restart execution means after this one. Okay, if you have any piece of code, it will start execution here. Once it has hit the end of the block, right, it will get rid of method 2, it will go back to method 1. The reason is because whenever you finish something, whenever Java finishes any operation, right, Java finishes executing any method, right, it needs to know where to go. For that only it uses the stack concept. Okay, so say for example it is executing the method 1, okay, and it has successfully executed the method 1. Immediately it needs to know where it has to go. So it will look into it wants stack trace. Okay, it will keep a trace of what all the things. Okay, so it knows that it has executed method 1 successfully, so it will get rid of this one and it will know where to go now. It has to go back to main. Okay, so that is how the stack works. Now why I explain this concept to you guys, right? Method call is, right, if an error has happened here, right, it will go back and search here immediately. Whenever an error has happened, whenever in a Java, right, whenever an exception is being thrown means, right, it will search for the catch block immediately, try catch block. Okay, if you don't have a try catch block in the method 3, right, it will search for the try catch block in the method 2, because from the method 3 it has gone, the exception has been thrown to the method 2, and the exception has been thrown to the method 1, and then the exception will be thrown to the main, and then from main to the JVM. So you can handle the exception in any place here. Okay, let's do this demonstration itself. Okay, let's do that one. Okay, pretty sure I can do it perfectly. I'm not going to muddy this one. I'm going to create a bunch of methods. That's all I need. I'm just going to replicate it. Okay, I'm going to call this method 1, method 2, method 3, and method 4. And then so this will call method 2, this will call method 3, this will call method 4, and then here I'm going to put that 1 divided by 0. Okay, now I'm just going to call that. Oh shit. What class? Now, okay. Now when I execute this one, right? Oh, sorry, no, I missed one thing also. I just want to put this one so it is clear where the before statement is coming from. Okay. When I run this one, right? So if you look at the error, right? You get before 1, 2, 3, 4. The reason is, so it will execute this line and it will come here, it will execute this line. So that's what before 1 is. It will call this method 2, and then again it will come inside method 2, it will print out the before this 2, and then the method 3 will be called again the 3, method 4 will be called again 4, and then here what the error has happened, which is what is the line 35. So immediately what it will say is like, what you are seeing here is like, so you are seeing Okay, what is the cause of the, what is the information about the error? Okay, what type of error? It's arithmetic exception, and then it is a divide by zero error, and then you're seeing the stack trace. When you remember here I said the stack trace, right? It goes inside, it puts inside the stack everything. Okay, so first it will put the main, and then on the top of main it will put method 1, on top of that method 2, on the top of that method 3. So how it will print out is, it will print out first method 3, then method 2, method 1, and main. Okay, that's what you're seeing here. Okay, first it will print out where the error has happened, that belongs to method 4, and then from method 4 it is go back to the method 3. Okay, so here again it go on it will search for a try catch block here. There is no try catch block here also, so it will jump here, so it will keep on printing out. Okay, and then it will go back to the main, and then from the main it will come outside. That's what the last thing you see. Okay, from the main it will go back to the JVM. Now you can have the try. So for example, you have the try block here, try catch block. It's simple. Okay, you'll see the after statements also now. The reason is the exception has been handled here itself. Okay, it is just printing out the stack trace, how where this method 4 has, how the method 4 has been called. Okay, how the method 4 has been called. Method 4 has been called from line number 28, which is method 3. Method 3, how method 3 was called from method 2, line number 21, and then where the method 2 was called from the method 1, and then what line number was it, 14, and then it goes like this. Okay, so you have handled the error here itself. Okay, exception, you have handled it will look for the catch block, it has got the catch block, and then exception will be handled here. It will do whatever operation it wants, and then it will carry out the operation normally. Okay, so that's why you're seeing it. Now say for example you don't have this. Okay, let's cut out this one. Let's go back to the original. Okay, now you can handle the exception here also. Okay, if you do this, remove just remove delete this one. Okay, so method 4 is what, when I call the method 4, I'll just expand this one so that you can clearly see. See the piece of line where I call the method 4, right? I have put that inside the try block. So once it calls the method, right? Once it calls the method 4 from inside the try block, right? If an error being thrown, right, it will go inside this child class method, right? That can be handled by the parent class methods. Sorry, parent method. Okay, which method calls it? That method can handle the exception thrown by the sub methods. Okay, so the error has happened here. Immediately there is no catch block here, so this piece of code won't execute it. So it will come out of this method, and then it will look for a catch block here. Yes, it does. There is a catch block, and then an error will be handled here, and then it will carry the operation normally. And then like this way, right? You can go you can go deep. Okay, you can have the try block here also. Okay, now let me remove the try catch block here, because if the exception is handled here, means like no, it is just a method call. It will never print out this one. Okay, that's fine. You see here, only after one has been printed out. Okay, the reason is exception has been happened here. It will go back here. It will look for a catch block. There is no catch block, so the line of execution will jump automatically from here to the where it has been called. Okay, it has been called from here. So again, there is no try catch block also here also. So it will jump here from immediately here to here. There is a try catch block, so the catch block will be handle the exception that is being thrown, and then you are seeing the print. From there onwards, it will carry the operations normally. Okay. This is how the exception handling will be propagated. The reason why I'm saying this one to you guys is right. Tomorrow when you do the program, right, when you create methods and a lot of things, right, many times what will happen is right now the method which you are creating, right, that can't handle an exception, that can just propagate the exception to the caller. Okay, so it will ask the caller to handle it. Okay, that is where the checked and unchecked exceptions comes into the picture, and there is another keyword called as throws. Okay, and we will see that in the next session, okay, what it is. Okay, so this is, I'm fairly confident you guys would have understood what is try catch and finally, okay, what is the purpose of it. But to get around this stack concept alone, like now, just go through the video again and see how it was how the exception was thrown, propagated from like method to method, okay, method 4 to method 3, method 3 to method 2, method 2 to method 1, okay, and then just look into that that concept also, okay. What is stack? That last in first out, queue first in first out. What is that concept also? Okay, it will be a bit clear. Okay, once we see what is checked and unchecked exception, right? It should be fairly clear. Okay, whatever we saw this one. Okay. Okay, guys, I will just upload this video probably tomorrow morning itself. Okay, so that others also can see, because many of you guys didn't attend the session. Okay. Okay, Greg. I will see you next Monday. Okay. I'll inform you guys when I do that one. Bye, Jiva. Okay.
Bye. Bye.